Hello everyone, I'm Amulya BR of Sri Venkateshwara College of Engineering and I belong to the branch CSE AI. Today I'm back with another subject, NoSQL, and on the topic Concurrency in Database Management System. So let us look into the contents. Introduction to Concurrency in Database Management. What is concurrency? Importance of concurrency control, concurrency control mechanisms, locking protocols, deadlocks, isolation levels, optimistic versus pessimistic concurrency control, the real world concurrency challenges. So first let us see concurrency in database management. Concurrency is that which will allow multiple transactions or operations to execute simultaneously, thereby improving the system's efficiency, responsiveness, and also the resource utilization. It is crucial in multi-user environments where several clients or the process might handle the access or modification of data at the same time. The proper concurrency handling ensures that the data is consistent, it is accurate, also there is integrity despite concurrent operations. Without adequate concurrency management, the database will risk issues such as deadlocks, or inconsistent reads, which can compromise the data reliability. So the effective concurrency techniques are very much essential in high transaction systems like banking, e-commerce, and the social media platforms. So next, let us see what is concurrency. Concurrency refers to the simultaneous execution of multiple tasks or the transaction within a system. So in database systems, this will involve multiple users or applications accessing, reading and writing the data concurrently. So the concurrency will enable efficient resource usage, and improved system throughput as it will allow the task to progress without waiting for others to complete. However, concurrency also introduces challenges like ensuring there is data consistency and managing the dependencies among transactions. Effective concurrency management is very much critical for handling the high demands of modern and multi-user database environments. So, and also balancing performance and data integrity. So now let us see the importance of concurrency control. The concurrency control is essential for maintaining the data consistency and preventing conflicts in a database when multiple users or applications will access and modify the data. Without control mechanisms, simultaneous transactions could lead to anomalies like lost updates or dirty reads and uncommitted data being accessed. Concurrency control will ensure that transactions will operate in isolation, thereby preventing any interference and preservance in the database's accuracy. So the effective concurrency control will boost the system's reliability. So it will also minimize the transaction conflict and will enhance the user trust in the applications, which is especially critical in the fields that requires high data integrity like in healthcare or in any finance industries. So next let us see the concurrency control mechanisms. Concurrency control mechanisms will manage the simultaneous transactions to maintain the data consistency and isolation. Common techniques are locking, timestamp ordering, and validation based methods. So the locking is nothing but it prevents the concurrent access to the same data by restricting the transaction execution. So the timestamp ordering is nothing but it will ensure that the transactions will follow a predetermined sequence. Then next is validation based methods. So these are often used in the optimistic concurrency control and validate transaction changes before committing it. So each mechanism has its own advantage and drawbacks, typically chosen based on the application needs. So such as balancing requirements with the risk of data conflicts. So now let us see what is locking protocols. So locking protocols are the techniques that are used in database to prevent multiple transactions from accessing the same data simultaneously, which could lead to conflict and data inconsistency. So the logs can be exclusive or shared. Also, there are two-phase locking. So this two-phase locking is very much common protocol which requires transaction to acquire all the necessary logs before making any changes and releasing them only after all the operations are complete. So the properly implemented locking protocols will help to preserve the data integrity, though they may also introduce performance bottlenecks and potential deadlocks. The locking protocols are very much important to maintain and achieve the data integrity. So the next one we'll see what is deadlock. Deadlocks will occur in a database when two or more transactions are waiting on each other to release the lock. So this will create a cycle of dependency that will halt the progress of any process. For example, if transaction A will hold a lock on the data item X. So here, for example, we'll see the process 1 is holding already the resource 1 and it is waiting for the resource 2, whereas the process 2 is already waiting, it is already having the resource 2 and it is waiting for resource 1. So this resource 1 is held by process 1. So hence it creates a cycle. So this cycle is called deadlock. So this will have no progress. So deadlocks can cause the system slowdown and resource wastage. So to address this, the databases will implement deadlock detection mechanisms and prevention strategies like lock ordering or any priority systems. So next is isolation levels. Isolation levels in a database defines the degree to which a transaction is isolated from others, impacting how visible the data changes of one transactions are to other. The four main isolation levels are read uncommitted, read committed, repeatable read, and serializable. So at lower levels such as read uncommitted, the transaction might see uncommitted changes from the others. So this will increase the performance at the cost of consistency. Then higher levels like serializable will provide strict isolation but it will reduce the concurrency. So the choice of isolation level will depend on the application which needs to balance with accuracy as well as the performance. So next let us move to the optimistic versus pessimistic concurrency control. So the optimistic and pessimistic concurrency control are the two approaches to managing concurrent transactions in a database. So the pessimistic control will assume the conflicts are likely using logs to prevent the other transactions from accessing the data until one finishes. So this is very much common in applications where the data integrity is critical. Optimistic control will assume that conflicts are very much rare, so this will allow for the transactions to execute freely but verifying changes before committing. So optimistic control is often used in high performance systems with low contentation. So this will reduce waiting, but it will also risk the conflicts at commit time. So let us see the real world concurrency challenges. So some of them are scalability and also the distributed databases. So the concurrency will possess several real world challenges, particularly in high demand applications like e-commerce, finance and telecommunication. So the common issues include handling deadlocks in transaction heavy systems. So preventing data corruption in high concurrency environment is also another problem, and also balancing performance with data integrity is also another challenge. Scalability can also be challenging as increasing concurrent users will strain the locking and isolation mechanisms. Additionally, the diversity of applications with varying the concurrency needs, such as the real-time data processing versus the batch jobs. So these will require adaptable concurrency strategies. So addressing all these strategies are essential for reliable, efficient, and scalable database systems. So that's it. I would like to thank each and everyone for watching the video completely till the end. I also request you to please like the video and share the video amongst your friends. I'll make sure to come back with another video on a different topic. Until then, have a good time. Thank you.